The first speaker is Professor Pietarinen, and he will talk us about philosophy of notation in the Tractatus. So, Professor, you're welcome.
Good morning. Thank you very much. What a lovely way to start the afternoon, in fact, with a discussion on Tractatus. Wonderful idea. So I will share the screen with you and let me know if it doesn't work out. I just need to find the way to do it with Zoom. Sorry about the hassle at the beginning.
Я слышал, нет, слушайте, мне так кажется, что там как раз это кафе носило такой.
Does anyone know how to share the screen with the Zoom? I'm pressing the share the screen, and then what I get is oh, okay, here is this thing right here. I hope you can see the slides. The philosophy of notation in the Tractatus. Let me know if this doesn't work. Just greetings to all about the World's Logic Day. This is the one day when we can be logical. It's a quote from Peirce that's closely connected to what I'm going to talk today about the Tractatus. When he says the world hates sound reasoning as a child hates medicine. I think that's still true today, so it's important to have this occasion. So in the Tractatus, Wittgenstein makes the claim that logical constants do not represent anything. They don't represent the world. The logic of the facts cannot be represented. And I wanted to tackle this not representing assertion from the point of view of the philosophy of notation, which is an old way to approach logic, which is somewhat different from being only philosophy of logic or philosophy of language. It's an area of its own to look for principles that underlie all logical notations. It comes from Peirce's 85 paper on the algebra of logic. It's not interested only the question of syntactic or semantic equivalences. So even if you have expressively equivalent systems, you might find important differences in the way those equivalences are being expressed in the logical notation. And so what it is interested in is, for example, the informational and observational contents of logical signs, logical notations. And so the Wittgenstein thought that logical constants do not represent, because there's a fundamental defect in the notation of logic. And let's see a little bit about this. So the argument from Tractatus is that first, the truth operation is different from truth function. Wittgenstein says that the occurrence of an operation does not characterize the sense of a sentence. The operation does not assert anything, only its result asserts, and that it depends on the basis of the operation. So the operation and the function are different. And secondly, the sense of a proposition is how the proposition agrees or disagrees with the possibilities of the existence and non-existence of elementary facts. So for example, if you have the occurrence of the operation like conjunction in the first, here it does not characterize the sense of that proposition, because that proposition has the same sense as the one that uses implication as in the second formula, and there is no conjunction in that second formula. And same, for example, having a negation sign in front of a proposition, it does not characterize the sense of the proposition. You can have double negation or no negations. And so the third is about the sense, which is the same. That sense is then the truth table with Wittgenstein's linear notation. It is take the proposition P, take Q, and then take the valuation true, false, true, true. And that sense is not affected by the way it is presented in different logical formulas. Okay, so I look briefly about these claims of Wittgenstein. Logical constants do not represent. And secondly, when he talks about elimination of equality, the sign of identity from logical notations. And then secondly, the notational ideal for logic. I'll actually begin with that. There's an extension of this issue then in Peirce's graphical logic, which is a characterization of the logical constancy, which may come close to what Wittgenstein wanted to have, but didn't quite have in his own work. So the notational ideal is that all and only logically equivalent propositions are represented by the same sign. And the question is, are there logics that fulfill this notational ideal? Now, Wittgenstein had proposals for this, most famously perhaps the N notation. There are others, like the AB notation. But in N notation, it doesn't quite capture the notational ideal phases, because, for example, you have Nn of PQ, and you have Nn of QP, a commutation there, and these are syntactically distinct formulas, although they are logically equivalent. Same with repeating the N, for example, once or 3 times, and they are syntactically distinct formulas. The broader claim is, which I'm not going to go into details here, is that the notational ideal obtains in the graphical way of notating, representing logic, and those logical constants involved in this graphical notation could then be said to represent, given that there's a way to view them as notationally ideal notation. So here is just give an example. For example, the first concerning the NNP and Q and NNQP are not syntactically distinct in graphical notation, because in the space, commutation comes from the property of that space. There is no rule to express commutativity or associativity. It's not needed. It's not there. It cannot even be expressed in the system. And secondly, when you have these circles that correspond to N, these are called cuts by Peirce. If you have 2 of them, they cancel each other if the space between them is blank. So this can always be done. And in fact, it's an observational fact that this can be done, that you observe that the space is empty, and then you can add or remove these 2 occurrences of that boundary. And in fact, topologically, if you take that boundary to be an operation such as a twist in a quotient space, then you don't have any difference between having 2 of these operations or 0 of these operations. They are not even syntactically distinct. So that's an observational fact, and so the ideal is in this sense achieved in that notation. And the reasons behind this is that truth functions, the idea of the truth functions and collectional function belong together. The collectional function of that graphical oval or the cut is also having the truth functional service in the system. And that gives the new notation. So there is more information informational content added to that notation. And so one piece of a notation can do more than one purpose there. And so that's a characterization of logical constancy. Now let's look at quantification and identity. This is also from Tractatus, when he says, Wittgenstein says, the identity of the object I expressed by identity of the sign, and not by means of a sign of identity. And again, he thinks because there is a fundamental defect in the notation of logic, that equality has got to be eliminated from the system. Now, if you think of this in the graphical terms, I will just very briefly present some examples of that. We begin with the idea of the sheet of assertion. There's actually a sheet behind Wittgenstein and von Wright here, which is Wittgenstein's own sheet from his bed when he was staying with von Wright in Cambridge. It's from 51, I think, the photo was taken. So that's already a constant. The sheet of assertion is already a constant that expresses all truths. And then you add very simple piece of notation there, which is basically that there is a line that comes from the idea of a loop, in fact. So the loop is very basic. And when that loop is moving in space, it creates the line, and that's called the line of identity. And here you already can observe a difference between graphical way of notating logic and then what is done by, let's say, conventional means using quantifiers and variables, because in fact, there is no way in that traditional way of expressing to express an identity between three, x equals y equals z is not a piece of notation in the standard language, whereas you have in class what's called the ter identity, identity between three, and that is also a basic element of that system. So in fact, there are just these circles, two kinds of loops or circles, boundary and the circle. Here, just using different colors here to distinguish between them. So, for example, this one is that it's not the case. Something exists that is identical to itself. That is logically equivalent to everything is non-identical. And Wittgenstein says that some have tried to express the thought that there are no things by writing that not exists, something equal to itself. If this were actually a sentence, wouldn't the sentence be just as true if there were things, but such that no thing was identical with itself? So this is a kind of an example of what Wittgenstein will call pseudo-proposition. It cannot actually be written down. For example, think of expressing a non-reflexivity. There are such things as non-reflexive logic. So this is in fact, one way of thinking about that. That's, let's say, in quantum theory, it's being proposed that it might do some work. But anyway, this is just to give you an example of how to express in a very simple graphical system what Wittgenstein said are in fact pseudo propositions. And this is also, I wanted to briefly point out that this is interestingly related. This is actually a special case of Moses Schoenfinkel's not exists and operator from 1924. I wanted to mention this. I mean, Schoenfinkel is, of course, a Russian, and this result is not that well known that it is also a generalization of Sheffer-Stroke and Peirce-Arrow, both come from Peirce 1880, generalization of that to first order logic. So you can express first order logic with that one operator only. That's Schoenfinkel's next and. And this next and is really graphically what is expressed here in terms of the loop that has, in fact, two ends or two loops at the end of a line, and that would be that one single operator by which you can express the whole first order logic. So I think that's an important result. Almost a century ago, so we can celebrate Schönfinkel when the time arrives in a few short years again. And by the way, if you know anyone in Russia who knows something about Schönfinkel, or you know someone who knew Schönfinkel, that would be very important, because not that much is known about Schönfinkel's life. He only published 2 papers, and then he sort of disappeared somewhere in Russia, and almost nothing is known about his life, a later life, what happened to him, or what did he do in Russia. So if you know anything about him, that would be quite important. So here is just one more example of expressing that everything is identical to itself. You could take that as an axiom. And here is a way to express a non-identity. There are 2 things that are not identical to themselves, like this. And then you can add predicates in that system like that. But I wanted to go to Wittgenstein when he says that the identity of the object I express by identity of the sign, and not by means of a sign of identity. So for this, we could speculate that that's the line. That's all you need, is to have a line to express that. And then he says that difference of the object I express by difference of the signs. And the difference of the sign is to have 2 ends of a line that do not connect continuously with each other. Then he says about the identity sign, roughly put, to assert that 2 objects are identical is nonsense. So that would be nonsense. Whereas to assert that one thing is identical with itself says nothing. It's also a pseudo proposition. It says nothing. A is identical to A. And that is expressed by the loop. And therefore, the identity sign is not an essential part of logical notation. It has got to be eliminated. Okay. So some conclusions from this is that then now also quantification and identity belong together. Notationally, there is a unification of quantification and identity. And that's what Wittgenstein says. The sign of identity is the identity of the sign. So we don't eliminate identity in favor of identity as a predicate or something else that's been proposed. It's just a one continuous line. It's a variable-free notation in that sense. But that line, which is a quantifier, does also the work of the identity. And so there are these pseudo propositions that I mentioned that Wittgenstein says it cannot even be written down. And there are many in the graphical notation. You have self-identity, symmetry, transitivity, commutativity, associativity. Those are the things that there is no way of expressing those as rules, because they follow from the notation itself, or from the properties of that ambient space in which you embed these topologically interpreted pieces of logical notation. So that's a way to unify logical notation, characterizing constancy from those properties of topological space. And maybe that's something that Wittgenstein might have been quite interested in discovering himself or learning about. Now we know that he learned something, mostly through Ramsey, and took some interest in the work and philosophy by Peirce, but did not quite, probably didn't learn about Peirce's logic that much. Ramsey learned something, but probably there it breaks down, so he didn't convey those particular pieces of information from Peirce's work that Wittgenstein might have been the most interested in. Okay, so I will conclude here. The famous proposition, the boundary of my language is the boundary of my world. This could be understood or read if you follow the proposed reading of Tractatus that has been given in Bazzocchi quite recently, that Tractatus might have been intended to be read strictly according to the numbers of the propositions. You know, section X.3 before section X.4, even though there are subsections between those propositions. So the main propositions follow consecutively. So in this way, when you have the boundary of my language, that is not read after the preceding propositions, sub-propositions, but directly after 5.5, 5.6 after 5.5. And 5.5 is the proposition that every truth function is a result of the successive application of the operation there to elementary propositions. And what is this operation? Well, that is the Sheffer stroke and how to achieve the truth functional completeness of the Sheffer stroke. So 5.6 follows, so it's a corollary from the argument from Sheffer stroke, or take Peirce's notation, Peirce's loop and oval, as the only sufficient operator in logic. And this includes first order logic as well. So Tractatus 5.6 should thus be read that the boundary of my notation is the boundary of my world. Okay, and I will leave it at that. And thank you very much for your attention.